Hello everyone, I will present our paper, CityGuard, Citywide Fair Risk Forecasting using a machine learning approach. Urban fairs occur in cities or towns, causing much financial loss, many injuries, and even death. From the reports by International Association of Fair and Rescue Services, there were over 3 million fairs in 2017. Last year, a major fair engulfed the Notre Dame de Paris, destroying priceless treasures. If we forecast the fairs in future, the rescue departments can deploy the fair control facilities in advance and take steps immediately. Therefore, it is necessary to forecast fairs. Traditional fair control deployment is based on the statistics and analysis of specialists, but they are coarse-grained in temporal and spatial dimensions. With widely used of neural networks, many works study on spatial-temporal forecasting by using data-driven methods, which can reduce the efforts of specialists. We can predict fair risks of regions in a city to assistance of the rescue department. To rank the fair risks in a city, we face two main challenges, temporal challenges and spatial challenges. From the temporal aspect, the fair risk of a region is influenced by internal effects and external effects. From the spatial aspects, we need to consider local spatial attributes and global spatial dependencies. For local spatial attributes, we use POIs, which related to the population in a region. For global spatial dependencies, we analyze the spatial distribution of fair incidents. To overcome the challenges, we design a machine learning model named NeuroFair to integrate temporal and spatial aspects. The model consists of two steps. The first step is temporal fair classification. We classify whether the region will catch fair in future. The second step is spatial fair risk forecasting. In this step, we rank the risks of regions which will catch fair. To forecast fair risk at current time step, we use GRU CRF to combine external and internal effects. For external effects, we use GRU to learn temporal representation of external features, and use CRF to learn the dependencies between time steps. To learn spatial dependencies, we need to consider the fair risk differences among regions. We transform the fair risk forecasting problem into a pairwise comparison in spatial. We conduct the experiments on a 59-month real-world dataset. It is collected in Zhou, China. In addition, we use some datasets about urban, for example, POI in city weather and incommons data. To evaluate our model, we use 4 metrics: recall, F1 score, AUC, and MAE. We compare our model with 9 baseline methods. From the results, we learned that our model outperformed than others. Our model performed better than Lasso, CRF, LR, and SVM because we use GRU, which did well in learning the temporal representation. Compared with GRU LR, combining GRU and CRF learned the internal effects better. And our model using SBPR to model the spatial dependencies got the good results. Finally, We visualize the results of baselines to demonstrate the effectiveness of our model. From the figures, we found that our model distinguished the regions which will catch fire, while ranking the risks of regions. The results show that it is important to consider temporal factors and the spatial dependencies.